All right, so this will be the first example for our graphical method. So suppose that here that we do have a graphical example of Blair's factory produces two products, which is the spoon will be the X1 and fork will be the X2, X sub 2. Our goal here is to maximize the profit and given the constraints on labor and materials. So in that case right now, if I want you to identify, suppose that identify the graphical method example, so if you wanted to identify the graphic examples, you have to just put right there x1 and what will be the number for the x1 later on. Here, so the number of spoon to produce and x2 number of fork to produce. That is for the defining of the decision variable. That will be the step one that must be there, must be present accordingly since that will be the um, steps that you will need to deal with in your future, especially into your examination. You have to deal with that one accordingly. So in the next one, it will be the same thing that you will be going to deal with um, here. For the step two, you have to identify, excuse me, the objective function, which Baleares Company earns a profit of 40 pesos per spoon and 60 pesos per fork. So therefore, what you need to do, since your objective is to maximize the total profit, so you have the z is equals to how much? So it will be 40x1 and 60x2, something like that. So it will be like this. So that will be your objective functions right now. So afterwards, we will deal with here. Um, excuse me for a moment. Okay, here, just a second. All right. So now, what you will need to do right here, you will be going to identify the constraints as well. So suppose that this will be the given constraints right now. His factory has limited labor hours and material supply. There will be two constraints given that there is a limited labor hours and material supply. So here then, our labor constraints, each spoon requires 2 hours of labor and each fork requires of 3 hours labor. His factory is 180 total labor hours and available per day. So what we'll need to do with that one, excuse me, so we can just put as like this, 2 x1. So let me see, 2x1 plus 3x2 and less than or equals to 186. 180 is our maximum total hours of labor hours available per day. So that's how you will identify that here. So afterwards, for the material constraint, it will be the same thing. Each spoon requires 4 units and of materials, and each requires 5 units for the fork. Now, this factory has 200 units of material availability. So in that case, since there will be availability of like that, it will be for x1, then plus the 5x sub 2, which is less than or equals to 200. So that must be like that. The equations that for the defining the constraints, that will be the answer actually. And then for the step four, you have to define the parameters. So you just have to deal with that. The profit per unit. So that is 40 pesos per spoon and 60 pesos per fork. Then the labor hours required right there. What we were able to identify earlier, that is 2 hours per spoon and 3 hours per fork. So material required, that is 4 units per spoon and 5 units per fork. And total labor available, that is 180 hours, and total material available, that is 200 units. So afterwards, you have to include non-negativity restrictions. You just his company cannot produce negative quantities of spoons or forks, which is x of 1 must be greater than or equals to 0, and x of 2 must be greater than or equals to 0, something like that. That's absolutely easy. Now, as what I mentioned to you for the step 6, there will be sub-steps that we need to identify. So it must be step by step right here as well. Now, you have to maximize z, that is equals to 40x sub 1 plus 60x sub 2. For this one right now, given that your 2x1 plus the 3x sub 2, that will be the constraints. You have to identify the x and y constraint, you will moderate it later on, maximizing this one and matter with the constraints later. We'll be going to deal with that step by step. Now, this will be the sub steps. So what I mentioned to you that there will be a sub steps that we will need to be going to deal accordingly. Now, the first step right there for for the step six, there will be five sub steps. Now, for the 6.1, you have to find the x and y intercept for each constraints where you will need to put, for example, the x is 0 or the y is 0, what will be the value for that one? You will need to deal with that later on. You'll be going to have it in the example so that it will not be vague for you. Now, you have to plot the feasible region. You have to plot the graph and then you have to identify where is the feasible region. So you just have to put a shade, something like that. It will be basic for you. Then you can somewhat put this is the feasible region. So feasible region. So say for example like that. Then identify the evaluate corner points afterwards. That will be basic for you, I know. So identify and evaluate the corner points. You will have to evaluate that step by step later. I will begin to deal with that. So calculate the objective function for each corner point and choose the optimal solution. Now, this will be the example. So first, you have to find the intercept for constraints where your labor is 2x sub 1 plus 3x sub 2 and less than or equals to 180. So what you will need to do right now, given we will have to find the value of x sub 1 where your x sub 2 is 0. So your x sub 2 you have to put here as a 0, then you have to find the x sub 1. So what we'll need to do right now, something like this. So identify 2x sub 1 plus 3 times 0 step by step. You have to step by step everything. So after multiplying, it will become 0 here and 2x sub 1. Then it will be equals 180 because that is 180 the maximum amount. And afterwards, you have to omit the 0 because 2x sub 1 plus 0 is still 2x sub 1. So it will become like this. Afterwards, you have to divide that into 2. Both of them, you have to divide here 2x sub 1 divide 2 and 180 divide 2 as well. So it must be like this. Let me correct that one so that it will be clear for you, everybody, in the PowerPoint presentation, so that it will not cause any hassle for you as well. So it must be divided by 2 as well here. Divided by 2, na, something like that. So it must be like this. 2x sub 1 divided 2, then 180 divided 2. So cancel 2. So it will become 1x1. So it will become x1 here. Then your 180 will be divided into 2. You have to simplify that one. So your x1 right now is equals to 90. So therefore, finding the x1 where your x sub 2 is 0, your x sub 1 is 90. So that is basic. Now, you will put into consideration the x sub 2. You have to find x sub 2 where given x sub 1 is 0. So what you will need to do right now is do the same thing. What you will need to do is the same process as what we have did earlier. So here, you have to still do the same thing. So 2 times 0 plus 3x sub 2. So it will become 0 plus 3x sub 2 is equals to 180. So you have to divide that in copy as is. You need to step by step accordingly. You have to remember that will be the step by step because so that you will earn the designated point as well. Now 3x sub 2, you have to divide both by 3. So let me also correct the presentation so that you will really understand the step by step for that. Because I don't want you to I don't want you to be confused with regards to that one. Now, let me go ahead and show it to you in a second. Here, just one moment. All right. So become like this. Here, just a moment. All right, so it's been done. Okay, so it will become like that. 3x sub 2 divided by 3, then 180 divided by 3, so cancel 3 will become x sub 2 is equals to 180 divided by 3. So 180 divided by 3, that is 60. So currently right now, if your x sub 1 is equals to 0, since we are finding the x sub 2, it will become 60. So that will be your, in general, for finding the labor constraints for the x and y intercept, if we are finding the x sub 1, if we put x sub 1 into 0, it will become x sub 2, 60 if we are finding the x sub 2. If we are finding the x sub 1 where your x sub 2 is 0, it will become 90. So thus, your intercept right now is a given 90, 0. It will not be going to be interchanged class because of course that will be the intercept. So say for example here, this will be your x axis and your y axis here. So that will be your x, y, and x right now. Now, so suppose that we are having that in a graph. Since our x1, this one here, x1, it will be 90. So this will be your x, and this will be your y. Now, since your x right now is 90, suppose that the 90 is here. So this will be our 90. Suppose. That's absolutely an example just for you to know that is our 90. Now, this will be our representation. Okay, it will be your representation for that. So x sub 2 is 0. So your x sub 2 is 0 here. That is your x. No. I'm so sorry. Um, it's not correct. Let me re-identify that. Okay, just a second. It's not all right. Let me erase it. Okay. Now, suppose that we're having here. Okay. Just a second. It's absolutely not working. Here now. All right. So here, there's the eraser. Because I don't want you to be confused with that. Suppose that we are absolutely doing that in a drawing. Now this will be your y, and this will be your x. Now your x right now is 90. So this will be your 90 here. 90. Since that is your x, and your y is 0. So 0. So since your x is your y is 0 and your x is something like that, suppose that you will put here then. Now, if you are finding your x is 0, so 0 on x, then your x sub to your y axis will be 60. Suppose that your 60 right now is absolutely in there. Let me picture it out for you. Suppose that here will be the 60. 60. Yan. So that will be your representations right there. Now, what you will need to do, you will plot here, for example, 60, and that will be linear. So I'm so sorry what happened to our line. So say for example, that will be your your x and y axis right now. So that is 90, 0, and 0, 60. That will be your intercept. So for the material constraint, it will be the same thing. For x sub 1 plus 5x sub 2, where is equals to 200. Now we need to find the x sub 1, which your intercept given is x sub 2 is equals to 0. So what we will need to do here is it will be the same thing. You will have to apply the same approach. So your for x sub 1 times 5 times 0 is equals to 200. So it goes to 0, then copy as is. Since 0 it will be added here, so it will become 4x sub 1 still. 4x sub 1 divided by 4, so it will be 200 divided by 4 as well. So it will become x sub 1, 200 divided by 4, it will become 50. So your x sub 1, intercept given that your x sub 2 is 0, it will become 50. So that's how you will be going to deal with that accordingly. So fix this. It became like now. All right, so it will be something like that. Now for your x sub 2, given that your x sub 1 is 0, it will be the same thing. 4 times 0, 5x2, then 200. 0 plus 5x2, then 200. And 5x2 is equal to 200. 5x sub 2 divided by 5, it will become x sub 2. Then 200 divided by 5, it will become 40. So you're given that your x sub 2 is, you're finding that one, then your x sub 2 is equals to 0, so it will become equates to 40. Now, it will be the same thing if you will be going to apply that in a graph. So your if your x sub 1 is 0, so x sub 1 is 0, your x and your y is 40. So suppose that we have here the 40, so you will plot that here. Say for example, then suppose that your x sub 1 is 50, that will be your x sub 1 is 50. No. X sub 2 is 40. So that is y-intercept. So suppose that here is your 40. And we'll plot that here, 40. Then suppose this is 50 for your right now. This is x sub 150, then 0 is your x sub 2, which is the y. So it will become something like that. So that will be the that will be your basis right now. So the next step, you have to plot the feasible region. How to plot the feasible region? You have to plot both of the x and y axis for both of the constraints in one graph, actually. So before you can identify the feasible region, you have to do the graphing first. So identify the feasible region in all graph, which are the area which are the constraints overlap. You will begin to identify where they overlap actually. So as what I mentioned to you, that they can access in both of that grounds. So let's try to see here. So this will be the because I've actually made a program that could easily draw here, because for drawing it will takes a lot of time for me. So now, so given that your constraints earlier, you were able to have the y axis as 60, then your x axis is 90, then 0, then x axis is y axis is 0, 40, and 50. So where is the feasible region right there? Because this will be your for example, this will be your material, and this will be your what other material, as well as the what's the other what's the other okay, labor. Okay, suppose that this is your labor here, and this is your material. So your material right now and labor can access only here. So only in this part. So that means to say they overlap in each other here. That is their visible region. That's why if you can see right now that this is shaded in a gray color, because that is visible. That is really can be achieved, or I mean both of the constraints can definitely access in that particular space, because your material constraints cannot access here in this kind of field for your labor constraints. That's why this will be your feasible region right now. Now, shaded with the gray visible solution space where all constraints are satisfied, so that they are satisfied in each other for that one. That's how you will identify the feasible region. Afterwards, you have to identify the corner points. By identifying the corner points, you will just have to enumerate all of the corner points, which are those x and y intercept that we were able to get earlier, basing on the x sub 1, if it is equals to 0, and x sub 2 is if it is equals to 0. Those are the how we will begin to identify that in the actually. So for this one right now, let me go ahead and show it to you. There will be a 0, 60, then 90, 0, 50, 0, 0, 40. That's our implementation, what will happen. So afterwards, this will be our basis right here now. So evaluate the objective function at each corner point. So you have to evaluate already using the maximization profit formula. What I mean. So what we'll need to do is definitely something like this. you have to use already. Then given that your plot or the you will use this feasible region 060, so therefore you have to evaluate each cases. So right now 40, your this will be your x1, this will be your x2, this will 060 is our first function that we'll be going to deal. So 0 is your x1 and 60 is your x sub 2. So how can you deal with that? It's basic actually. So let me run it through. So what we call this, I mean, what we can process is um something like this right now. 40 times a 0, then plus 60 times 60. So it will become 0, then 3600. So your maximization profit for this given um, region will be zero for the 060 is 3,600. So that's how you will deal with that one. Now afterwards, what you will need to do is for the maximization profit for the 90, you have to also evaluate that one. So 40 times 90, then 60 times a 0. So you will do the same thing. So 3,600, then 0, then 3,600 is your maximize your profit right now. And afterwards, you will need to deal with here. For the Z is equals to for the same thing that you will need to use. Then your feasible region is using the 50 a 0. So what you will need to do, 50 is your x1 and 0 is your x2. So calculate 40, 50, it will become 2,000, then 60 zeros equals 0, then 2,000 is your maximization result. Afterwards, you have to maximize the profit with the 40 region. So 40 times 0, 60 times 40, it will become 2,400 and 0, so it will become 2,400. Now, you have to evaluate and choose the optimal solution afterwards. Since we were able to have the results already earlier, so you have to put right here 060 region, it will become 3,600, and you will need to identify if it is feasible or not. So given that earlier, if you can remember that um our linear graph, something like that, this will be your labor and this will be your material. So given that your feasible region is you have to identify. So 060 is not feasible because that is here, for example. And your 90 is not feasible as well because that cannot be um accessible by our um, material constraints. So therefore, they are not visible, although that they do have they do equates with more profit. So we don't need to include them. So for the 50 that is in visible region, so that is 2,000 feasible. However, that's not an optimal solution. So for 040 to 400. So comparing the two, since they are feasible to each, actually, so the optimal solution will be this one, since our goal is to optimize the problem. So it will become 2,4 is our optimal solution. So that's how you will deal with that one. So here in your final graph, you can identify, since we were able to identify already the visible region earlier, so you can select the optimal solution. So your optimal solution right here is given in this thing right now in your 4040. I've actually put a red in your program. So to explain that one, to maximize the profit, Balearan's factory should only produce forks 40 units and not produce spoons. So that will be the explanation on how to deal with that. So I'll be going to discuss as well another example in another video. So see you there.